Keerthi is a DLT blockchain technologist. His main responsibility is to provide technical expertise to SMEs and UK businesses to help them adopt and exploit blockchain technologies to solve real-world problems. He is a committee member of BSI and contributes to the standardization of smart legal contracts. He is an industry associate at UCL Centre for Blockchain Technologies and previously a subject matter expert for the Oxford Blockchain Strategy Programme at Said Business School. Before joining Digital Catapult, he founded a tech company that specialized in self-sovereign identity. Thank you very much.
Thank you, Leo. Can you hear me?
Yes, thank you.
Thank you. Thank you for this opportunity to share my experience on the Weather Ledger project. Yeah, it's great to follow up on both Josh and David. What I'm going to cover is about the technical aspects and mainly the challenges and the opportunities we have in using DLT in this space. So I'll start off with a brief introduction of the company I represent. It's called Digital Catapult, and I'll kind of run through a little bit of why we work in this space and what is our role in the Weather Ledger project. Digital Catapult is multi-vendor, vendor-neutral, multi-technology company whose main focus is on helping SMEs and SMEs to implement and adopt latest technologies. So while attempting to do this, we actually interact with various organizations from both academia, SMEs, government departments, and also investors. We in some ways identify solutions, match up with, identify problems, and then match up with the solutions from potential solution providers, service providers. And then we also link them up with investors to help them fund their projects. So in terms of working with the government, we are funded by the UK government by indirectly as Innovate UK, who funds various research projects within the industry. In terms of policy, our organization sits between BASE and DCMS. You can look up those terms. For those in the UK will know those two departments. And also we look at multiple technologies. We don't just specifically look at DLT, but also look at 5G, AI, augmented reality, cybersecurity, and so on. We kind of spread across various parts of the UK. We have labs spread across the country, and we also have partnerships across different universities in the UK. But the most interesting part for this talk is especially with using of DLT in the construction sector is this approach that we have called DLT Field Labs. You know, there's to some extent, if you'll see when we mention blockchain, it's a word that some of them might even run away from because of all the negative connotation it has with all the ICOs and all that has happened in the last couple of years. But the technology itself can be used in non-fintech area, and we want to exploit that technology for other sectors, not just in payments and the financial sector. And we go about trying to identify the problems in manufacturing and creative sector specifically. And here what we try to do is we got a consortium of or a bunch of companies in the construction area, and also other allied fields like, you know, the companies like Clyde & Co and other legal firms to actually see what are the kind of challenges that are there where blockchain can be used, or here distributed ledger technology can be used, and to just minimize this, or remove this hype that's there with the in adopting blockchain technology. Our aim is to not try to do anything bombastic, but try to take one small step towards implementing, small measured step into implementing and using this technology, and then scaling it into a production system. That's the aim of, or that's our focus. And we use this field lab approach, where we discover, um, develop small incremental solutions, and then deploy it, measure it, and then again, it goes through an iteration to scale the solution. So that's our approach. And Weather Ledger has been one of the outcomes of the field labs approach, where we've been able to identify very specific problem with the weather compensation events, compensation claims rather, where adverse weather seems to impact the relationship of companies in the construction sector. And what I'm going to do is, I'm not going to go into what Josh and David have already talked about, but I'm going to zoom in more on the technical side of things. Okay, we understand measuring weather data is problematic, because on the construction site may be many miles away from a weather station, and therefore you don't get a reliable source of data, and therefore you have disputes arising from that. So how do you, and so what we what we have addressed this is through deploying sensors on the site, and then of course coupling it with a DLT to oracleize it, and then also use smart legal contract to arbitrate the claim. And what you're actually seeing right now is the high-level architecture of the system. We do get traditional data or historical data into the system, but more importantly, what we are trying to do is use weather sensors on the site itself, and then connect it to a smart legal contract. But there are certain challenges of building this, and that's one of the things I'm going to talk about. And the other thing is, okay, we've heard about smart legal contract, that is automating some of this, some of the NEC some of the clauses from NEC contract. How do we actually go about it from a technical perspective, and what are the kind of challenges we've been facing? So in terms of weather data, we've actually been able to deploy more than 5 sensors across England, and we've been able to monitor and capture data on almost on every 10 minutes, I would think is right now the frequency. Josh can correct me if I'm wrong. And so one of the main challenges of taking the data is it's not good enough. It's to just simply capture the sensor data and pipe it to a smart legal contract. And the entire pipeline has to be secured. And that's one of the major challenges we have found. How do you actually ensure the end-to-end security of the pipeline? And okay, if you want to use a distributed ledger and store the data, but garbage in is garbage out. What you put in is what you get out as the truth. So how do you actually ensure that the sensors themselves are not tampered with? I think that's one area that requires some amount of research. In fact, perhaps right now actually we are looking at some AI techniques to actually see if is the data captured by the sensor abnormal than compared to what it was, what it should have captured based on historical data. Now, because yeah, you could actually you could sabotage this sensor for various reasons, and we need to have a very secure way to we need to have a way to say capture the integrity of the data that's been captured on the system. So that's one thing, and the other is also about how do we know that the data that's captured is coming from a sensor, from the sensor that we know it should come from. So that aspect again needs to be fixed. And here we are looking at provable is one of the options, but still there is some gaps in terms of okay, we do encrypt the data in stages, but we need to have a complete encryption of data, and also need to ensure that the data is oracleized. And one option is to use like services like Provable, and this is what EHAB is using right now. The other aspect relates to data availability. I mean, this is, you can, from a technical perspective, this may look like a non-functional requirement, but this is absolutely critical, which perhaps is not was not on our radar initially, is things to monitor like battery level, or even the mobile contracts, to ensure the data is available, and and to proactively monitor and to ensure that the entire system or the underlying hardware is in a proper state to produce the right amount of data. Because as I said, you know, if we put incorrect data into a distributed ledger, you only get an incorrect data out, and that may not be the source, the single source of truth. So the other aspect that we are that Digital Catapult is giving help on is or is helping we are trying to give or do the technical due diligence is the smart legal contract. Most of us who come from the technical space understand smartly a smart contract. Okay, you have Ethereum or any of the public chains that offers facilities to change the or have facility for changing the state of the ledger, and you can do that using a piece of code that sits on top called the smart contract. Now, how do is that more useful in implementing a contract that will arbitrate and arbitrate a claim? While most of the techies will say yes, that's the best way, but we know that it's problematic, it's contentious, because code cannot be the law. How do you actually, I mean, we've had these issues in the past where there have been bugs in the system, and how do you actually hold a person responsible? So what, can we actually somehow take imprecise code or very imprecise legal text and bind it to program which is very precise in its by definition? And how can you actually get them to bind together so that we, even if the code malfunctions, you have the or if not malfunctions, but if there's something were to go wrong, you actually have some you have the legal text to back up your claim, or to at least understand what was it that you tried to implement, and what was the legal basis for the smart contract. And one option was to, you go using, you can actually use a smart contract on Corda, where you can just attach a PDF of the text, or the legal text can be attached to smart contract. But then you could also go through the other options like open law, which has a slightly more tighter binding. But what we found the best approach was to, or what we found really good in was the smart legal contract option from the EHAB project, because it not only helped you to extract the legal text, but it also helped legal text in terms of clauses and contract, but it also helped you to extract the models and the logic, business logic from the very fuzzy legal text, and keep them in one place and bundle them together and deploy them. And therefore, in our analysis of all the different types of systems that we've seen, we found smart legal contract from the EHAB project really the most sophisticated one in the area or in the sector so far. So how does the smart legal contract look like? What I'm showing you right now is from the EHAB project. As you might see, a typical smart legal contract, a smart contract would have looked like this on the right-hand side. Logic, you have some logic, it compiles, and it compiles into a code, and then you deploy. But what the smart legal contract option gives you is all the other bits, where you can actually have your natural language contract extracted as a clause text, and that's bundled with your data model and logic, which can then again be generated using a parser, which can actually, you can actually use a parser to generate a smart clause, and which can actually be bundled along with your compiled code and deployed. So what you have is a much tighter binding of both the legal text and the program code when it's deployed. So that's, but then, as I said earlier, there's it comes with challenges, because these are two very different two very different artifacts. One is very, it could be vague and imprecise, and one, and it needs special interpretation. That's the legal text. And then you have a program which are very, very precise. So that comes back, that leads us to, what are the type of challenges that we face. So the main challenges is developers are not, are not legal experts, and should not try to translate legal text into a smart legal contract. That should be done by experts or legal experts, and they are definitely are more, or they are the only ones trained to do that. And that means two types of professionals working together, the legals and the developers, and trying to get them to come up with a system that can actually be used is something new for us. And I've been in the IT for a long time, and it's quite interesting how we approach this problem. But there are, and right now we are working on this solution. And the other part is, we can only automate certain parts of the contract. Like NEC contract is around, it's more than 100 pages, if I know. And we cannot automate the entire contract. We can only automate parts of it. That means the smart legal contract, the code, needs to make references to the external artifact. Here it's the NEC contract, and that again requires requires both collaboration of legal professionals and developers to actually see how that link can happen. And that's again another opportunity for us to work together. So I'll just leave you with that, and if you have any questions, you can please drop in, and you can even contact me if you have any, if you want to collaborate. Thank you.